Hello everyone and welcome back. So in this video I'm gonna guide you through the process of exporting everything you see in here, all this scene, into Unreal. So that sounds like an easy task, but actually is not that easy because my scene, as you can see, is a bit of a mess, and I want to create instances, so I don't use the full geometry because that would be overkill. This scene, I believe it has around 10 million polygons, so you can see it here because they are packed primitives, but only this lamp has a lot of polygons. I can't really show you because they are packed primitives. So let's see how we can solve this. And one more note, as you can see, for example, in this object here, I am using a copy and not a copy to points. I'm using a copy and transform. So we need somehow to extract the points from this copy, and that's another issue we will face. So let's see how we can do this. So we have the scene, and let me show you an example. I have a name attribute for each piece. So for the pillars, for the seats, for the walls, everything has its own name attribute. So let's see. We can check lamp holders and delete non-selected. So we have this. How can we extract the points? Well, these are packed primitives, so we can basically use an add and delete geometry but keep points, create a copy to points just to test if this was gonna work, create an object merge, and let's load the lamp holders. So as you can see, I have a null at the end of each object, so I can easily transfer them to Unreal. So I have the lamp holder. Let's make sure we place it in the center, and let's copy to points. So this is actually working, but this setup would break in another scenarios. Let's say if I select something else like plaster walls, and I go in here and select plaster walls, and I copy to points. As you can see, it's not the same, only because I have done some transforms after packing, so that won't work. And sometimes I am also unpacking the packed primitives. For example, in here, I believe, yes. So in here I want to do some UVing on all the instances and not only one, so I can have some variation, and for that I need to unpack, and after that I lose all the transforms, even if I place an attribute wrangle and try to extract the transform from the packed primitives. So let's see. You can see we have the transform, but is not oriented properly. So what's the solution? Well, there are a few ways. An easy way I found, and it was suggested to me, is to, let's skip this one. is to use a for loop and use transform pieces, I believe, not transform pieces, but rather extract transform. So let's see how we can do that. So let's say for each point, and let's set it to primitives, so we have each one, and we can use this object merge, and let's unpack and use an extract transform. And the extract transform connected to here, and we should have this. And now if we copy 2 points, we should have everything back, as you can see. So exactly the same result. We could try to do it with a single extract transform, but from my tests it didn't work properly, at least in my scene, because I have some strange transformations on the packed primitives, and unpacking again, so everything gets a bit of a mess. So this is the way it's going to work, and that's what I'm sticking to. And now we need to find a way to automate all of this, because right now we're only placing one single object, one single name attribute. So let's test with another one. Let's go for the lamps, and in here let's say lamps, and it should work the same way. Oh, we need to make sure we pack the primitives. We need to make sure we pack an instance, otherwise it will be really slow. So as you can see, it's working properly. And again, if I go back to the plaster walls and plaster walls, you can see in here on the points that we have an orient attribute that is working correctly, as you can see. So as I was saying, we need to find a way to automate all of this, because right now we only have one object being processed. So what we can do is to run another loop, so for each named primitive, because as I was saying, I have a name attribute for each part of the scene. So I have here the name. If I run it, and you can see if I set the single pass, I have the altar, I believe that's the name in English, I'm not sure. Then I should have the ceiling and the other parts, including the floor and the pillars and whatnot. So we also need to make sure we export only the necessary geometry. For example, in here we don't need to export all of these, but just one, and then we export the point clouds, and we can instance in Unreal. But for example, for the floor, we can just create one in Unreal, but let's export it. And for that we won't need a point cloud, and this is not packed primitives, so we need to find a way to filter the type of geometry. The same goes for this part that I can't really instance. I guess I could, but I'm not going to. And also this part in here, that I could instance these objects, but it's just not too much geometry, so I'm gonna export these as a single mesh with the respective materials and whatnot. So let's keep for now. Let's select, for example, this part in here, and now we can place this loop. So let's duplicate it and place this loop in here. We also need this, and we will need, let's just color this in a different way, and we also need the meta. So let's call it meta, and in here we will need to select the respective geometry that is currently being processed. So let's add a spare input and connect the meta, and we will need to use an expression in here. So in this case we will use this, open backticks, and say details because it's a string attribute, and we will grab the meta nodes and use the value attribute that it will have the name. So as you can see, it's grabbing the correct objects, and let's see, now we have the proper point cloud. Let's just get rid of this. Let's see if it works for another one. So this one is the lamps, but for example, if we say it's 0, it won't really work. It's just unpacking. First of all, it's not finding a single mesh, and it's unpacking everything, so this won't really work. We need to find a way to filter this. So the way we're going to do that is by using a switch in here. So let's create a switch, and we will select the geometry coming and this part in here. So in this case we will set it to 0, and this should be working. So when is not a packed primitive, we will have the output as the single mesh, and when we have another, let's say this one, we will have the points, not this one, yes, this one, we will have the points, yeah, there you go. So in this switch we need to find a way to filter it. So the way we're going to do that is by using an expression. So if we go in here and we go to the geometry spreadsheet, primitives. As you can see, we have the ceiling in here, and let's go into intrinsics and find packed intrinsic type name, yeah. As you can see, we have an attribute that is storing the packed geometry name, let's say. So what we can do is to filter in here. So we can use an expression. Let's open it, and let's use string match, and we want to find packed primitives. Let's just say packed wildcard, and then we need a string attribute, so we use prims and input 0, and we need to find in here the name, which is intrinsic type name. So intrinsic type name, and this should be good to go. Let's accept it, and let's see if this works. So for now it's working, it's selecting the input one. Let's set it to 0, selecting input 0, 1, 2, 3. So I decided the windows will also be a separate mesh. We could easily instance them, but let's keep that for now. So we have the points, 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 and finally the seats, as you can see. So everything is working as expected. So in the end we will have something like this to export. So now let's also set up the Unreal instance attribute. So we can just come in here and place a wrangle just for simplicity, and let's say on points string at Unreal instance, that's the name, and let's say is the detail -1 and value, just the same attribute we used before, and is going to error out. We need to add a spare input and add the meta. So this won't actually work in Unreal, but I mean it will work, but it won't grab the correct object in Unreal because we need the reference path. But as we don't have it right now, we can just say it like this, and then we can replace it in Unreal. At least we will have a slot to introduce the instance we want. You will see how it is later. So we have this, and let's see the geometry spreadsheet, and let's select this, and let's see, we need on the point Unreal instance. As you can see, we have the seats and whatnot. We should have everything. Alright, so now we need to export the single objects, so the seats, the lamps and whatnot. So for that, what I'm going to do is let's create a null in here. Oops. and create a wrap FBX. And in the wrap FBX we will need to set some things. So I just created an output folder, output file in here that is going to out-cathedral fbx demo out.fbx, but we will need a more precise name. So what we can do is to, instead of out.fbx, we will add a detail attribute in here, details in this case because it's a string, and we're going to select the meta node, so meta, and we will need the value attribute as before, and this should be good to go. So as you can see, this will give us seeds.fbx. I don't have a single pass, yeah. So now let's say we will export the seeds, but we also need to export the single geometry, or the geometry that is not packed. So for that we will need a switch, and we will say if n points, if the number of points of the incoming geometry is equal to 0, select the second input. So in this case we can just grab from here and we can export the geometry. So let's test this out. We have the seeds. Let's place, for example, the altar, and if you select in here, as you can see, it's selecting the number 1 because we don't have geometry in here. So this is correct. Now we need to automate the export. We need to press this button automatically. So for that we will use a Python node, and let's place it in here, for example, and we can just say out.parm, and let's go for obj. Just select the paths of the node to export. So geo1 wrap fbx 1 and slash execute, and then we just need to execute press button, and this should give us what we want. So obj geo wrap fbx execute and press this button. So that should do the trick. And what else do we need? We need to, let's see, so we also need to group the points so we can separate them later. So let's group. So let's say points unreal and select points, and this should be about it. Let me see, we have already the Unreal instance, and yeah, let's try to export this. So let me select this one, enable this one, and check single pass, and let's export it. So as you can see, it's rendering the geometry. It shouldn't take too long, so it's already done. So I navigated to the folder, and let's see if the geometry is in here. And indeed we have the altar. Let's check the glass. Should be pretty fast. And let's say the pillars, which should be just one. As you can see, the file size is small, apart from the lamps. This is a bit high poly, but we have everything needed to export it to use in Unreal. So now we will need to export an HDA with all of these points. So let's do that. Let's blast the points Unreal. Delete non-selected. So this point cloud, each one containing Unreal instance attribute. If I enable it in here, so as you can see, we have the seats, the pillars, the lamps, the lamp holders, and whatnot. So let's disable that. And now the way I'm doing this, you need to export it in a way that you don't have, you need to create an HDA that doesn't have inputs. So I can't really export all of this. So what I'm going to do is to create a wrap geometry. Let's copy the path from here. So this, and let's say ip geo out fbx0, and let's say point Unreal VO2. We will export it as VGeo because it will contain all the point information. So let's save it, and now we can use a file and load those points. So there we have it, and you can see we still have the attributes. And now what we can do, and this is really important, we need to middle click in here and select the absolute path and paste it. So we need actually absolute paths, otherwise this won't work. But it's pretty simple, you just middle click and copy. So select it, create a subnet, and let's say point Unreal demo. Let's save it, and let's go to digital asset, create new. Let's say we want in the IP file directory, and we don't want a prefix. So points Unreal demo, and let's create it. Let's apply and accept. So now we have everything, and we should be able to recreate the scene in Unreal. So before we go to Unreal, I forgot a very important step. Here in the wrap FBX, we need to say zup converts to specified axis system and convert units. So because in Unreal is centimeters and here is in meters, So that should fix it. And if we run again the loop and we say reset cache path, it should export everything again. And the points should be okay, but just in case, you can export them again, and in here reload and save node type. So here we are in Unreal. Let's try to import everything. So before we import, let's create a new level. File, new level, empty level. Let's also create a directional light. Let's say something like this. And let's import our points. And let's drag them. As you can see, it's creating the point cloud. And now let's import the geometry. So geo out demo, and let's import everything. So in here, make sure you don't tick convert scene, and let's see, we can leave everything default, no translation, no rotation, and uniform scale set to 1. Let's import it. So everything is imported. As you can see, we have some materials that came with it, but we don't need to worry. So now we can go back to Houdini. So in here we have the points. If we go to the geometry spreadsheet and see the Unreal instance, so the first one will be the ceiling, then lamp holders, lamps, ornaments, and so on. So let's go back to Unreal and let's select the points. Let's go to the first component. Let's go to general and select ceiling. Then we have the lamp holders. So let's select the second one and select lamp holders, so it's in the correct place. Now let's select the lamps. So the lamps. Then we have ornament windows. So ornament windows. Then we have pillars and plaster wall and seats. So pillars, plaster walls, and finally the seats. Then we can drag the single meshes. So let's drag the altar, the doors front, the floor, the glass, and that's about it. So let's drag them to the scene and reset the transforms. So let's see. Let's try the altar and reset. So let's also make sure we reset this that was in the wrong place. So let's first reset this, and now let's drag the altar, the doors front, the glass, and the floor, and let's reset this. So everything should be working. So this is the demo scene that I'm working on. I already set up some materials and some lights and god rays. Maybe I will continue on this subject in the next videos, let's see. And I hope you have learned something new today. Thank you for watching.